The next problem that we're going to look at involves looking at the area of a rectangle. So remember that the formula for finding the area of a rectangle is A equals L times W, where A stands for area, L stands for length, which is the long side, and W stands for width, which is the short side. So if we look at this second problem, it says the width of a rectangular picture frame is 3 inches more than its length. The area enclosed by the frame is 130 square inches. What dimensions does the picture frame have? So we want you to follow through all of these steps to be able to get full credit for this question. The first one says to assign a variable. So with this one, we're talking about area being the length times the width. So it kind of makes sense to just decide that we'll let width equal to W and length equal to L. Then forgive the formula. That's what we just talked about, that the area is length times the width. Then it says write an equation and solve it. So of course for that part we need to determine what we know and where it needs to substitute. So remember from what we just talked about, the width is the short side. So this one is going to be W, and L is the long side. This is L. And let's see what it says. The width of a rectangular picture frame is. So that means it's going to give me something about the width. And it says it is, which means equals, 3 inches more than its length. So whatever my length is, if I add 3 to that, I will get my width. The area enclosed by the frame, so that's all of this in here, right, is 130 inches. So what I know is my area is 130, and I can represent width by the length plus 3. And we're just going to let length equal to L. So now all we need to do is substitute this into our formula. A equals L times W. So we know A is 130. We don't know what L is, so we're just going to write L for the length. But the width we know can be represented by that L plus 3. So what we've got here is an equation again. We're going to need to do 2 things. First, I need to distribute on that right hand side. L times L is L squared, and L times 3 is 3L. And then we can only be equal to one number anytime we have to solve an equation. That one number is 0. So I'm going to subtract the 130 from each side. And we end up with this equation. So we need to factor it. Thankfully, A is 1 again. So I know that C is negative 130. So my factors, you can start with 1 and negative 130 if you want. There's a lot of factors of 130. You could do 2, 3, 5. There are going to be a bunch. You don't have to list all of those out. We know that we need a set of factors that will add to 3. And a lot of times when you have numbers that are in the hundreds, like 130, is 130. Oftentimes, you will find that they're divisible by 10. So that's one of those hints that you can always at least give it a quick try and see if it works. So it could be 10 times negative 13 or negative 10 times positive 13. We're trying to get b equal to 3. So we're going to want the negative 10 and 13. So when a is 1, we can just use our factors directly. So we know both of the first spots are L. And then we have a negative 10 and a positive 13. Now we're going to set each one of the factors equal to 0. So adding 10, I get L equals to 10. Subtracting 13, I get L is negative 13. So if these are my only two options, and they are, we know that in the real world, length cannot be negative. So that means that we can exclude this one because it's not possible. So for the length, we know that that is going to be 10, and this frame was in inches. Then to get the corresponding width, what we know from the problem is the width was 3 longer than the length. So if the length is 10, then that means the width is 10 plus 3 or 13 inches. All right. One more. All right, so for this last problem, I'm sure you've heard the Pythagorean theorem before. This says in a right triangle, which just means we have a right angle opposite the hypotenuse, the sum of the squares of the lengths of the two legs, so the two legs are the two shorter sides of the right triangle, is equal to the square of the length of the hypotenuse. The hypotenuse is always the longest side, and it is always opposite the right angle. So Pythagorean theorem says if we square the length of one leg and add that to the square of the length of the second leg, that will equal the length of the hypotenuse squared. So just in general math terms, we usually call that a squared plus b squared equals c squared. Okay, so let's look at one. We have a wire is stretched from the ground to the top of the tower. So this is my ground down here. This is my wire. It tells me that the wire is 10 meters long. Then we have a tower, which is represented by this straight up and down side. It says it is 2 meters greater than the distance d from the tower's base to the end of the wire. That's a mouthful, right? So we know that this distance here is the tower. So this is the height of the tower. So that leaves this leg to be d, which is the distance from the base or the bottom of the tower to the end of the wire. So the wire is 10. We know this first leg here is d. It says the height of the tower is 2 meters greater than the distance d. So that means whatever d is, this is 2 greater, right? So we know for Pythagorean theorem with a right triangle, we can square the 2 shorter legs, add that together, and it should total the hypotenuse squared. So we're just going to substitute. It does not matter which one of the 2 legs you let be A and which one you let be B. Remember, addition is commutative, so that doesn't make any difference. The only one that matters is C always has to be the hypotenuse. So I'm going to say that this is D squared, that's this leg right here, plus B squared is equal to the hypotenuse, or 10 squared. So cleaning this up, this is D squared plus, be very careful here, and remember that squaring a binomial, that's not going to give me D squared plus 4. Remember that D plus 2 squared is the same thing as D plus 2, D plus 2. So you have to use FOIL, distribution, or the box method, either one. So if we FOIL that out, we get D squared plus 2D plus 2D plus 4, which is D squared plus 4D plus 4. So that goes in the place of the D plus 2 squared. Then 10 squared is 100. So we can say we have 2 like terms here. 2D squared plus 4D plus 4 equals 100. And I bet you can see where this is going. We have a polynomial, and it is not equal to 0. So I need to subtract the 100 over. So that leaves me with 2D squared plus 4D minus 96 equals 0. Again, you can look at this as a trinomial that has A not equal to 1. But again, it's always good to check for a GCF because it might help you out. And all of those are even numbers, so they are all divisible by 2. So I can factor out a GCF. Now, I put the calculator 96 divided by 2. That gave me minus 48 equals 0. So now what I'm left with is much simpler to try and factor. Because A is 1 now, we need the factors of negative 48. So we can start listing those again. There's going to be a bunch, right? Negative 1 times 48, it's divisible by 2. That would be 2 times negative 24, or it could be negative 2 times 24. And you can keep going, 3, 4. The one we're going to end up needing is 6 times negative 8, negative 6 times positive 8. We're trying to get B equal to 2, right? So we're going to need positive 8 and negative 6. So we know that our beginning terms have to both be D. And our factors are plus 8 and minus 6. So like the one we did before, when we set our factors equal to 0, it's only the ones that have a variable. So we don't have to do anything with the 2. So I'm going to set D plus 8 equal to 0 and set D minus 6 equal to 0. If we solve both of those, we get D is negative 8 or D is 6. And again, like the previous problem, the negative 8 in this problem can be excluded because in the real world, distance can't be negative, right? So we know that D is going to be 6, and that is a length, which in this case is meters. And it asks for us to find the distance D and the height of the tower. So the height of the tower was D plus 2. So if D is 6, then adding 2, the tower is 8 meters tall. All right, that actually concludes the material for test 1. I know that you're very glad to hear that. So I'll be working on turning back all of your homeworks, trying to get a review together, and I'll send out an announcement about the test. Thank you.